Hello and welcome to a digital lecture for Salt Lake Community College. This lecture will cover section 2.3 for Intro to Statistics, considering hypothesis testing. There are a lot of moving parts to hypothesis testing, and this video will simply discuss what those parts are. Please refer to examples demonstrated in the text, the example videos, and examples in class for more context on these concepts. A p-value is the probability of observing data at least as favorable to the alternative hypothesis as our current dataset, if the null hypothesis were true. It will be one of the most important values we will calculate in hypothesis testing, as it will tell us if we will reject the null hypothesis or not. A test statistic is a summary statistic of the data used to compute the p-value and evaluate the hypotheses. Using the p-value, we can claim whether a result is statistically significant, which means results that produce a p-value that is small, i.e. less than previously set threshold, that threshold being known as a significance level, and is indicated with the Greek letter of alpha. To put it all together, we say that data provides statistically significant evidence against the null hypothesis if the p-value is less than some threshold, often alpha equals 0.05. i.e., if the p-value is less than or equal to alpha, the results are statistically significant. We often use this threshold of 0.05 to determine whether a result is statistically significant. But why 0.05? Maybe we should use a bigger number, or maybe we'll use a smaller number. And it'll be good to be flexible and differ from the standard sometimes, because we tend to want a low value, but we'll see why more in a moment. Here's a quick example of some values for alpha and associated p-values. First, if we have alpha 0.05, the standard, with a p-value of 0.124, we notice the p-value is greater than alpha, so we say that these results are not statistically significant because p is greater than alpha. For the second, if we have 0.05 again, for p-value though, we have 2.3512 e negative 4. That is scientific notation. That really means 0.000235512. We would then say that yes, this is statistically significant because the p-value is now less than alpha. If alpha is 0.01, so a different value, and the p-value is 0.006, we again have statistically significant evidence because the p-value is less than alpha. And lastly, if alpha is 0.1 with a p-value of 0.272, we have in this case the p-value is too big, so we say no statistical significant evidence because p-value is greater than alpha. The table here will show the 4 different scenarios that can happen with hypothesis testing. Horizontally, we have the truth of the situation, which you should note we rarely will ever note the full truth, but consider yourself as all-knowing, and you are aware of the full truth for the time being. Vertically, we have the test conclusion we find. If the null hypothesis is true and we don't reject it, the top left corner here, then we made a correct decision. The same goes for if the alternative is true and we rejected the null hypothesis in favor of it, the bottom right corner, that's also a correct decision. The problem comes if we either reject the null hypothesis when it is true, referred to as type 1 error, or if we do not reject the null hypothesis when the alternative is true, called type 2 error. Both of these are problems that we want to try to avoid when conducting a hypothesis test, but as I said, it is hard to know the full truth, sometimes until it is too late, so we just want to limit the chance of these errors happening. The significance level alpha, referred to earlier, actually represents the likelihood of making type 1 error, which is why we used a 0.05, representing a 5% chance. Type 1 and type 2 errors actually have inverse effects, where if you limit the chance of one, then you make the other one more likely. So, if making type 1 error is more serious, then we tend to choose a smaller significance level. However, if type 2 error is more serious, we tend to choose a higher significance level. If you ever make the mistake of looking for data that supports your ideas, then you may engage in what is called confirmation bias, since you are looking for what proves your point and not for the truth. When conducting a hypothesis test, the symbol we use for the alternative can determine whether it is a one-sided hypothesis test, if we explore only one direction by using a less than or greater than sign. Or we could have what is instead a two-sided hypothesis test if we include both directions of possibilities by using a not equal to sign. We say that this tests both sides because we are then determining if we believe the true parameter is simply different, either higher than the assumed value or lower than it. It tends to be a good idea to keep an open mind when we analyze data and evidence. So we tend to say that we use a one-sided hypothesis test only if you truly have interest in only one direction. If you are doing a two-sided test, then you can actually find the p-value for one side and double that value to get the two-sided p-value, since the distribution should be roughly symmetric in shape. This smooth distribution representing the summary statistics due to chance is known as a null distribution, as it is based on the null hypothesis. As one last word of warning before we cover the steps of hypothesis testing, keep in mind that you should always hit up hypotheses before seeing the data. After observing data, it is tempting to turn a two-sided test into a one-sided test. Avoid this temptation. Hypotheses should be set up before observing the data. This is here twice because it is very important. Lastly, we have the 4 steps for hypothesis testing. For step 1, we have frame the research question in terms of hypotheses. You should set up your hypotheses first. Second, you will collect appropriate data with an observational study or an experiment. Thirdly, you will then analyze that data. And lastly, form a conclusion. If you have any further questions, be sure to review the example videos or ask your instructor.